This is a tutorial video showing how to set up physical animations in Unreal with models imported from Blender. So to begin, there are a few settings you have to check before exporting. First, you need to make sure the armature is named something other than armature. Or when you import it into Unreal, the scale and rotation will be completely messed up. So you can see up here in the top right, double click it and rename it. Next, when exporting, I'm going to export it as an FBX file. And on the right side, under geometry, you have to set smoothing to face, and under armature, uncheck add leaf bones. Then go ahead and export it. Once it's finished exporting, you can simply drag and drop into Unreal. Make sure animations are being imported and you are not using an existing skeleton. You can go ahead and set up your material. Okay, now to begin with physical animations, you first have to set up a physics asset. The default asset that Unreal auto generates is not very good. So go ahead and delete all of those default collisions. Now you're going to want to add a collision to every part of the body that should interact with the environment. And each of the collision boxes should be as close to the original mesh as possible. So for example, for the back part of the skeleton, I'm going to add a sphere because it's just about spherical. Now, on the right side here, you can set the size precisely. It's a lot easier to use than scaling this way. It can be much more precise this way. That looks about good. And just continue to do this until every body part has a collision. The next part is setting up the physics constraints between each of the physics bodies. This has to be done very carefully or everything will freak out when you simulate the physics. You have to start with a root bone, right click it, and add a constraint to a bone that's next on the hierarchy. You cannot do it in the reverse order, so you cannot right click the head and create a constraint to the root. You have to right click the root bone and create a constraint to the head bone. Same thing for the legs. You first right click the root bone and create a constraint to all of the leg bones that are the next higher up in the hierarchy. Then after that, continue to add constraints to bones further down in the hierarchy for the legs. It's important to keep in mind that you cannot move the constraints at all, at least for models imported from Blender, or else they will freak out when you simulate them. Once you're finished setting up all of the constraints, you can and should test how the physical animation settings will work on the finished physics asset. You can do this by selecting all of the physics bodies. Then in the bottom right, you can select new physical animation and assign all of those bodies to it. Once you do that, there will be a new tab under the details panel, and you can manually set all of the strength values for the physical animations. For orientation strength, you should generally use a value between 1000 and 20,000. And for angular strength, it should be between 30 and 200. All of these settings will affect how the physics works in different ways. You really have to just test them and play around with them until you find something that works for any given model. And when you're ready to test, you can click the simulate button at the top, and it will usually freak out when you have is local simulation checked, so make sure that's unchecked. You can test how each individual bone will interact with the environment or with the player's VR controller by holding shift and right clicking on a bone and dragging it. Again, you can toy around with all of the settings until you find something that works well. You can also test the animations at the top left by just selecting which animation you would like to test and seeing how it works. And as you can see here in this example, the constraint strength is too low, so the walking animation doesn't work properly. If you set it to a higher value, it should work better. Another important thing to note is the mass of each of the physics bodies. This will change how it interacts with environmental objects, falling, and how much the player's motion controller will be able to move the bone and the constraint when you hit it in VR. Now to set up the actual blueprint to use this asset in game, there are two different classes you can choose from, either the pawn or the character. For humanoid type characters, you would choose a character because you can't simulate the entire skeleton or it will lose balance and fall over. But for something like a spider whose center of gravity is very low to the ground and it has 8 legs supporting it, you can just go ahead and use a pawn and simulate the entire skeleton. Now to start, add a skeletal mesh, make it the root, and set the mesh to be the skeleton we just set up. And you have to make sure it has collision, either physics only or query and physics, or else the simulate bones won't work. Now to set up the physical animation data in the blueprint, we want to come up to add components, add a physical animation component, and just leave all of these values as the default. Drag it in, and we need a set skeletal mesh component node so we can set what skeleton this is going to apply to. We drag and drop our skeletal mesh, connect it, And we want to do this on event begin play. And the next part is going to differ depending on what your model is and how it's set up. There are different ways you can do this. You can use apply physical animation settings below, which when you type a bone name, such as our root bone, it will then take that bone and apply to all of the bones below it in the hierarchy of bones. So this will apply it to everything. You can also use this node to just apply it to one singular bone. Type the bone name there. But for our purposes, we're just going to use one of these nodes because we can just use one and not have to have any others. And we do not want to include the root bone. And we set the target of the physical animation. Now we need to make the physical animation data. Which you can do with this node. And we will use the values we found earlier that work well. Plug that in. And finally, we will set all bodies below simulate physics. New simulate include self because we want to include the entire skeleton. And for the end bone name, we will use the root bone. You can do that by making a variable, giving it the name variable type, compiling it, and typing spider root for the bone name, or whatever the name for your root bone is. Then you can drag and drop, attach it, and that should do it. Now to test it, you can drag and drop it into the world. Make that a little bit smaller. And start simulating the game. And you can see it seems to work. To test if the animations work, we can go ahead, create an animation blueprint really quickly. Add a new state machine. And let's test the walking animation. We also need to set that in the skeletal mesh anim class. Spider to 27, file save. Now it should automatically start playing. And you can see it works. So this should also work right off the bat with VR. If you're holding an object with a VR controller and you try to hit the legs or the head, it should interact properly with it. Another important thing to note is that if you use this method when the entire skeleton is simulated, all of the movement will be generated based off of the animation itself. The force of the legs pushing against the ground is what makes it move forward. And likewise, if we were to use a turning animation instead, it's the force of the legs pushing against the ground that makes it turn. And that's why this method isn't really possible for humanoid type characters, because if you try to walk with just two legs, it will easily lose balance. So if you were to use a humanoid, instead of simulating everything including the root, you would have to use a character class and only simulate, say, the chest, head, and arms, and keep the root bone unsimulated, and use the character style movement to actually move it around. There's a few different ways of doing it, but I think that's the simplest. And yeah, that's it for the tutorial. Thank you for watching.